Good morning, students. I am Abisha, Assistant Professor from the Department of Biomedical Engineering, working at Emmanuel Arasat JJ College of Engineering. Now we are going to learn about Thevenin's theorem. First, in the introduction part, we are going to see about how the electrical circuits look like. That is, the electrical circuit will contain many resistance and a sources. That is, sources is nothing but an voltage source and a current source. For an electrical circuit, there will be a complex circuit. That the complex circuits can be difficult to analyze. With the help of these theorems, we can analyze the compli- complicated circuit and we can find out the values easily. So, one among them is the Thevenin's theorem. So the network theorem will simply help to simplify this electrical circuits. Thevenin's theorem is one among that and which is one of the most useful network theorem which is used to analyze the complicated electrical circuits. Next we are going to see what is meant by Thevenin's theorem. The Thevenin's theorem, which is proposed by Leon Charles Thevenin. It is applicable for bilateral linear electrical network, a complex two-terminal network which can be replaced by a single electrical or equivalent circuit. That is, if the complicated circuit, we can find out the values for the Thevenin's resistance and the Thevenin's voltage. By simplifying that, we can draw the Thevenin's equivalent circuit which consists of an Thevenin's voltage VTH, Thevenin's resistance RTH and a load resistance RL. Next we are going to know about the statement for the Thevenin's theorem. That is, the statement is Thevenin's theorem states that any linear circuit with two terminals can be replaced by an equivalent circuit which consists of voltage source VTH in series with an equivalent resistance RTH. For a linear two-terminal network which contain a voltage source, a current source and a resistance which can be replaced by an equivalent voltage as sources VTH which is in connected series with an equivalent resistance RTH. So basic is that Thevenin's theorem statement states that for an linear network the circuit contains an voltage source VTH in series with the Thevenin's resistance RTH and a load resistance. Next is the basic Thevenin's equivalent circuit. For the basic Thevenin's equivalent circuit consists of Thevenin's voltage VTH, Thevenin's resistance RTH and the load resistance RL. For the equivalent circuit, Thevenin's equivalent circuit, there will be a voltage source and a resistance. That is voltage sources, Thevenin's voltage and the resistance which is Thevenin's resistance which is connected in series with the Thevenin's voltage and a load resistance. Okay, so this is a basic equivalent circuits look like after calculating the value of RTH and VTH. So the important terms which were used in the Thevenin's theorem are Thevenin's voltage VTH, Thevenin's resistance RTH and the load resistance RL. So these are the important terms which were used in the Thevenin's theorem for the calculation of Thevenin's equivalent circuit. For the Thevenin's voltage, we will open circuit the voltage across the output terminal. Across the output terminal, we will open circuit the voltage source. And next is the Thevenin's resistance RTH. For the Thevenin's resistance RTH, equivalent resistance seen from the load terminal. At the load terminal, across the load terminals, the equivalent Thevenin resistance RTH will be seen. Next is the load resistance RL, which is connected out the output terminal. So these are the basic terms which were used for the Thevenin's equivalent circuit. In this slide, we are going to see the procedures and the steps for the Thevenin's theorem. What are the steps which were used in the Thevenin's theorem? First is we have to identify the load resistance and remove them. Next, find the open circuit voltage, and after finding out the open circuit voltage, we have to calculate the Thevenin's voltage value. After calculating the Thevenin's voltage, next we have to deactivate all independent sources. After doing this, we have to calculate the Thevenin's resistance RTH. After doing this, we have to draw the Thevenin's equivalent circuit. For drawing the Thevenin's equivalent circuit, we have we need to find out the Thevenin's resistance, Thevenin's voltage, and the load resistance. By knowing this, we can draw the Thevenin's equivalent circuit. Next, we have to reconnect the load resistance. First, we will remove the load resistance, right? So after drawing this Thevenin's, for drawing this Thevenin's equivalent circuit, we have to reconnect this load resistance. After doing this, we can calculate the load current across the load resistance RL. For the calculation of the load current, we have one formula, that is load current IL is equal to Thevenin's voltage divided by load resistance plus Thevenin's resistance. So I am repeating the steps of Thevenin's theorem one more time. That is, we have to identify and remove the load resistance. Next is that we have to find the open circuit voltage, and next we have to calculate the Thevenin's voltage. After doing this, we have to deactivate all independent sources. Next, we have to calculate the Thevenin's resistance. After knowing this RL, VTH and RTH value, we can draw the Thevenin's equivalent circuit. By drawing this Thevenin's we have equivalent circuit, we have to reconnect this load resistance RL again. After doing this, we can calculate the load current IL, that is load current value, with the help of the formula. Next is what are the steps of procedure for finding the Thevenin's voltage VTH. First, we have to remove the load resistance. After removing the load resistance, we have to measure the voltage drop across the load terminal, which gives the open circuit voltage, also called as Thevenin's voltage. After doing this, we have to now redraw the circuit. After redrawing, we have to find the value of load current across the load resistance RL. The formula IL is equal to VTH by RTH plus RL. So I am repeating this. For finding out the value of VTH, first we have to identify the load resistance. Then we have to remove the load from the circuit. Next, we have to keep all the independent sources active. Next, we have to calculate the voltage across the open terminal. This voltage is VTH, and that after knowing this VTH, we can redraw the equivalent circuit. Next is the procedure to find out the Thevenin's resistance RTH, and the steps are we have to remove the load resistance first. Next step is that remove all the voltage sources, that is we have to short circuit the voltage source if the voltage source is given in the circuit. Next step, we have to remove the current source, that is we have to open circuit the current source if the current source is given in the circuit. And the last step is that we have to measure the resistance across the load terminal, which is Thevenin's resistance. So I'm repeating this step. First, we have to remove the load resistance. Next, we have to remove the voltage source. That is, we have to short circuit the voltage source. And if the current source is even, we have to open circuit the current source. After doing this, we have to measure the resistance across the load terminal, which is Thevenin's resistance RTH. That is, for an equivalent circuit, Thevenin's resistance is equal to equivalent resistance. After next is to find the load current IL. After knowing the VTH and RTH, we can calculate the load resistance, current across the load resistance with the help of the formula, that is IL is equal to VTH by RTH plus RL. That is, VTH is the Thevenin's voltage, RTH is the Thevenin's resistance, and RL is the load resistance. Once we know the Thevenin's voltage and Thevenin's resistance, we can calculate the load current across the load resistance easily with the help of this formula. Next, we are going to see one problems related to Thevenin's theorem. In this problem, there is a voltage source of V 12 volt and a two resistance were connected, that is R1 across the terminal A and B, that is R1 and R2. R1 as 4 ohm and R2 as 8 ohm and the load resistance RL as 6 ohm. Okay. So first step for this finding the Thevenin's theorem is we have to find out the Thevenin's voltage VTH. For finding out Thevenin's voltage, the first step is we have to remove the load resistance. That is, we have to open circuit at AB. Across the terminal AB, we have to remove the load resistance. After removing the load resistance, now the R1 and R2 form a voltage divider across the 12 volts. So we can calculate the Thevenin's voltage directly as VTH equal to V into resistance across second resistance R2 by sum of R1 plus R2. By substituting the value of R2 and R1 and an voltage source directly in this formula, we can find the Thevenin's voltage as VTH equal to a volt. And the next step is we have to find the Thevenin's resistance. That is Thevenin's resistance. For the Thevenin's resistance, first we have to deactivate the voltage source. That is, we have to short circuit the voltage source. After short circuiting the voltage source, now the terminals A and B contains resistance R1 and R2 are connected in series. That is, R1 and R2 are in parallel across the terminal AB. If the terminals R1 and R2 are in parallel, then we can write the formula as R1 into R2 by R1 plus R2. By substituting the value of R1, R2 directly in this formula, we can get the Thevenin's resistance as 2.67 ohm. After knowing the value of RTH and VTH, we can draw this Thevenin's equivalent circuit easily. That is, we know that for the Thevenin's equivalent circuit will contain a voltage source and a Thevenin's resistance and a load resistance. So by substituting the value of voltage source and the Thevenin's resistance in this equivalent circuit, we will get the Thevenin's equivalent circuit. After drawing the Thevenin's equivalent circuit, now the final step is we have to calculate the current through RL using the Thevenin's with the help of load current formula. IL is equal to VTH by RTH plus RL. So by substituting the value of VTH, RTH and RL in the load current formula directly, we can get the load current as IL is equal to 0.92 ampere. Similarly, there is a next problem related to the Thevenin's theorem. That is, in this problem, they have given the value of voltage source as 20 volt and the resistance R1 as 5 ohm and the resistance R2 as 10 ohm and the load resistance RL is equal to 10 ohm. So, from this circuit, first for finding out the Thevenin's according to the Thevenin statement, first we have to find the Thevenin's voltage, that is Thevenin's voltage VTH. For finding out the Thevenin's voltage VTH, first we have to remove the load resistance, that is we have to open circuit at AB. After open circuit at AB, now R1 and R2 forms a voltage divider across the 20 watt. So the VTH formula, we can put the Thevenin's voltage directly in this, that is V into R2 by R1 plus R2, that is by substituting the value of V and R1 and R2 value directly in the formula, we can find out VTH as VTH is equal to 13.33 watt. Similarly, next step is we have to find the Thevenin's resistance RTH. For that, we have to deactivate the voltage source, that is we have to replace the 20 volts voltage source with a short circuit. Now looking the terminals AB, the R1 and R2 will be parallel to AB. So we can write the for parallel formula as R1 into R2 by R1 plus R2 by substituting the value of R1, R2 in the above equation. We can calculate the Thevenin's resistance RTH equal to 3.33 ohm. After finding out the Thevenin's resistance value and the Thevenin's voltage, we can draw the Thevenin's equivalent circuit, that is VTH in series with the Thevenin's resistance and which is connected to the load resistance. So after drawing the equivalent circuit, now we can calculate the current IL across the load resistance RL, current through RL using Thevenin's theorem, that is IL is equal to VTH by RTH plus RL. By substituting the value of VTH, RTH and RL, we know the load current IL is equal to 0.1.02 ampere. So these are the basic problems related to Thevenin's resistance. Likewise, like this procedure, we can calculate the other Thevenin's problem similar using this basic steps, but the calculation will get differs. Otherwise, the problems are the procedure are same, and likewise this above problems. Next is the advantages of Thevenin's theorem. The advantages are it will simplify the complicated circuit easily. Next, for the calculation time, it reduces the calculation time. That is, some minimum time will be taken for the calculation purpose. For the load resistance can be find out easier. It is useful when the load resistance changes. When the changes in the load resistance take place, this theorem is applicable and helpful. Uh, it makes the circuit analysis easier. The circuit analysis can be done easily, and it helps in the maximum power transfer analysis. For the maximum power transfer analysis, that is Pmax, can be find out on the basis of this Thevenin's theorem. Okay, I am repeating these advantages one more time. It simplifies the complex circuit. It reduces the calculation time. It is easy to find out the load resistance. It is useful when the load resistance changes. It makes calculation analysis easier. It helps to find out the Pmax, that is maximum power transfer analysis, on the basis of this Thevenin's theorem. Next, the applications of this Thevenin's theorem. It is applicable in the electrical circuit analysis. It is used in electronic circuit. For the electronic circuits also, this Thevenin's theorem is applicable. For the power systems, the power analysis systems also, this theorem is applicable. For the amplifier circuit analysis also, it is helpful. And in the communication system process also, this Thevenin's theorem were used. For the calculation of maximum power transfer problems also, this Thevenin's theorem is applicable. That is, this Thevenin's theorem is mainly used in the electrical circuit analysis calculation, and for the electronic circuits, for the power systems, and for the amplifier circuits. Next, for the communication systems, and for the maximum power transfer problems. So I'm repeating this Thevenin's procedure one more time in a short format. First, the statement. The statement for the Thevenin's is, the Thevenin's theorem is that for any linear circuit with two terminals can be replaced by an equivalent circuit which contains the Thevenin's voltage VTH, and which is connected in series with an equivalent resistance RTH. So the RTH and VTH needed to be find out, and there is some sort of procedures for the calculation of VTH and RTH. For calculating the to finding out RTH, there is some steps, that is, we have to remove the load resistance. Next step is we have to short circuit the voltage source, and next step is we have to open circuit the current source, and the final step is we have to measure the resistance across the load terminal, which is the Thevenin's resistance. After finding out this RTH, next we have to calculate the VTH value. That is, for calculating the VTH value, we have to remove the load resistance, and we have to measure the voltage drop across the load resistance, which gives the open circuit voltage, and that voltage is called as the Thevenin's voltage. Now, after calculating the VTH and RTH value, next step is we have to draw the Thevenin's equivalent circuit with the voltage source connected in series with the Thevenin's resistance, and the load resistance will get reconnected across the Thevenin's resistance. After knowing redrawing this, we have to calculate the load current IL as with the formula VTH by RTH plus RL. So this is the basic procedures for the Thevenin's theorem. So that's all about the Thevenin's theorem. I hope all of you have understood this topic. Thank you all and have a nice day.